Okay, so today we're going to talk about 6-5b, identifying holes of rational functions. So this is going to go on page 79, so you may want to jot down up the top, page 79. And the homework for this is the same as the homework for yesterday. So the 5 problems that you did in the homework from yesterday, the domain, you're going to be finding the holes for them as well. So I hope that you left space. So when I talk about a hole, like what is a hole? It's just an empty space, like a gap, yeah. So if I'm drawing a hole in a rational function, do you remember the shape of a rational function? A hyperbola, yeah, right here. And what it would look like to have a hole in the hyperbola is this. So it might have like a tiny little gap right there. And it might not have a circle on it, but sometimes it might. It's just a place where the function is not defined. Okay, so it's just like an empty space. And they don't exist only on hyperbolas. Sometimes you find them in quadratics. So you might have like a hole in a quadratic, and a lot of times you see them in linear functions. So if I draw a linear function, I might have a hole right there. Okay, so what a hole is just an empty space where there's no definition, like the place is not defined in the function. And it doesn't just exist on hyperbolas. But what I'm trying to find here today is the holes on hyperbolas, the places where the function's not defined. And we already know that the function doesn't have a point, it's not defined. In fact, it's undefined on this. What is this? It is the y-axis, but it's an asymptote. Yeah, where x equals 0. Remember how yesterday when we found the domain, the answers were that the domain is all real numbers, but x cannot be something. Yeah, and you know how sometimes we had several x values that you couldn't have? Okay, we can't have x values where there's an asymptote. We also can't have x values where there are holes. So that kind of explains why sometimes there were multiple answers, right? So in order to find a hole, if there are common factors in the function that you can kind of cancel out on the bottom and the top, then there's a hole. And we're not always going to have holes in our functions. It's not something that we've really seen up until now. In fact, most of the functions that we've talked about don't have holes in them, right? You didn't see anything like that until probably today, maybe occasionally on like a PSAT prep or something like that, but you didn't see anything like that. So if there's common factors on the top and the bottom, then there's a hole in the graph. That hole is called a point of discontinuity. Can you say point of discontinuity? Oh, that sounded bad. Say it again. Point of discontinuity. Right. What does the prefix dis mean? And continuity is the adjective form of the word. Sounds like it, doesn't it? So to find holes of a rational function, first thing you're going to do is factor. Which, isn't that like a common theme with stuff in Unit 6? First step is to factor. Yeah. So you should realize that the first step is going to be to factor every time. So once you factor, you're going to identify and cancel factors shared by the numerator and the denominator, because that's where the holes are. And whatever you end up canceling, maybe you have an x plus 3 on top and an x plus 3 on the bottom, whatever you end up canceling, you need to set that factor equal to 0 and solve, because that's where your hole is. For example, if I have a function, and you don't have to write this is just extra. If I have a function f of x equals, and I factor it and it's like x plus 3 times x minus 7 over x plus 3, can I cancel anything on the bottom and the top? What can I cancel? X plus 3. And so what's left over? X minus 7, so the function really is f of x equals x minus 7, but since I canceled out the x plus 3's, that means that I need to set that common factor of x plus 3 equal to, yeah. So if x plus 3 equals 0, how do I solve for x to get the location of the whole? Minus 3, yeah. Minus 3, so my x value is, okay, so that's the x location for the whole in the hyperbola. But then if I want to go find the actual ordered pair, because it's a point, right? Like it's a point that's missing. So it's not just an x value, it also has a, and we've talked about this year, that when you have an x value and you have a function, what can you do to get the y value? You can plug it in. What's the fancy algebraic word for that? Substitute. Because x minus 7 was not the common factor. It's not what got canceled out. Right now, if I have the x value of the whole, then I need to find the y value, so I should substitute. Substitute where? Substitute negative 3 for x in the original function? Is there an easier way to do that? Just put it with x minus 7. So now I've found that x is negative 3. So f of negative 3 is equal to negative 3 minus 7, which is negative 10. Oh, I'm running off the screen, sorry. So my whole is at negative 3 comma negative 10 in the hyperbola. So I found the point that has that, like I found this point right here, where there is a hole. Okay. Yeah, it's not really that bad. And the instructions in the notes say find the domain. They were copied and pasted from the last notes. It should say find the holes. Find the holes of the following rational functions. So yesterday we didn't care about the numerator at all, but today do we care? Yeah, a little bit, because it might create a hole. So in number 1, step 1 is to factor, so I'm going to let you do that. Go ahead and factor. Okay, so I see some of you have factored, but a lot of you have just gone on, which is great. But all I really needed you to do at the time was factor. So if I factor the denominator, what two numbers multiply to give you 6 but add to give you negative 5? Negative 3 and negative 2. So my factors should be x minus 3 and x minus 2. Do you agree? Yeah. And what I have been advising my other class periods is that when you factor, you really need to rewrite the problem with all of the factors in it. Because sometimes I think that your work gets too cluttered and then you really don't know what's there and then you get things wrong. So rewrite it. X minus 3 is on the top. And on the bottom, we now have x minus 3 times x minus 2. Right? Do you see some common factors? Yes, x minus 3. So what can I do with them? I can cancel them out, and what remains is x minus 2 in the right. So if x minus 2 is in the denominator, then what belongs in the numerator? Agreed. Great. So that's a simplified function, which will be easy later to substitute something into. But since I canceled out some common factors, that means that I could possibly have a hole, right? So I need to go look where x minus 3 equals what? Equals 0. So I need to look where x equals positive 3. Good. And if x equals positive 3, how do I find the y value that's associated with that? Substitute into the original function? No, the factored function? This one? No, this one, right? I could do any of them. It'd give me the right answer no matter what, but it'd be way easier to put it here. So f of 3 is equal to 1 over 3 minus 2. 3 minus 2 is 1, and 1 divided by 1 is just, yay. So there's the whole. And in the last class, I told them that I pulled this up before. Yeah, Desmos, your old pal. I pulled this up before class, and I typed in the original function, and we found out that the whole was supposed to be at 3, 1, right? So if you go look in Desmos, it's actually not going to show you like a little circle. It's not going to show that to you because It's just not. It'd be too small to see. But if I go over to 1, 2, 3, comma 1, and I go click, get it actually on. There we go. Do you see that? What does that say? 3 comma undefined. So 3 comma 1 is the location of the hole, but when I actually go to that point on the graph, it says it's undefined because there's a hole there. So that's what it would look like if you checked it in some kind of software. It looked like it was undefined, but the location of it is 3 comma 1. So that's what I'm asking you for. Okay? Do you have any questions? Yes? Ask. 7 million questions. Okay, well then we're going to have to answer them one at a time. So number 2, first step is to factor. 2 numbers that multiply to give me 8 but add to give me -6 would be -2, -4. Good. So x minus 2 and x minus 4. It would be a great idea to do what with this problem? Rewrite it before I cancel. That way you can really see what's there and what's not. So x minus 2 is still the numerator, and x minus 2 times x minus 4 is your denominator. What common factors occur in the numerator and the denominator? X minus 2. So I should cancel them out, and remaining is what? 1 over x minus 4. Good. Don't make the mistake of just saying x minus 4 because it is in the denominator, so it needs to remain in the denominator. So if I canceled out a common factor of x minus 2, that means there's a hole when x minus 2 equals what? So there's a hole when x equals +2. Good. Yes. So in order to get the y value for that, I'd take 2 and I'd substitute it. Right. So f of 2 equals 1 over 2 minus 4. What is 2 minus 4? -2. The 2 here? Because I took the question was how did I get the 2? Because I found the factor that I canceled out. And when you cancel out a factor on top and bottom, that creates a hole. So you need to take that factor and set it equal to 0 and find the x value that gives you the hole. Okay? In order to find the y, you substitute your x value into the function and you calculate. So 2 minus 4, you're right, is -2. So the y value is. So on number 3, when you factor, what is this called? Like I don't need to factor the numerator, but what is the denominator called? Almost. Difference of 2 squares. So when you factor that, you need to square root both of the pieces. So what's the square root of 16? 4. Plus or minus 4. Good. So one of your factors is x plus 4, and the other factor is x minus 4. So I'm going to rewrite, because it's a good habit to kind of write a clean version. X minus 4 over x plus 4 times x minus 4. And it doesn't matter what order you write those in. Does it? What cancels? X minus 4 is the factor that cancels, so what remains is 1 over, correct, x plus 4. So since we had a pair of factors that canceled, that means that there's a hole where x minus 4 equals what? So I add 4 to both sides, I get x equals +4. So there's my x coordinate for where the hole is. But now if I want the y coordinate, then I have to substitute. Good language. So f of 4 equals 1 over 4 plus 4. And 4 plus 4 is 8. So you have 1 over 8. Good. Do not make the mistake. And I actually did it this morning. Do not make the mistake of just putting 8.
Yes, that's what I did.
Yeah, it happens. Don't make that mistake. So your notes are finished. These go on page, what did we say, 79? They go on page 79. But I want you to take out your homework because I want to look at the first problem. Questions have come up about how it looks kind of different. So take out your homework and look at the first problem. All right. This is problem 1 on your homework. It's been pointed out that the denominator from yesterday's work, you already did what to it? You already factored it. So whenever you factored this, you got -4 as the GCF, and then